negative. When the price increase in that way, quantity of demand reduced. So you get negative slope. You get negative slope also. If you get the demand function, at the price, there also you get the negative slope. So we have to understand why this happened. Why not happening when the consumers, the price increase? Why not quantity of demand increase? And why only this happened? Theoretically, there are some certain good. This also happened. And so the rationale that we have to understand, that's the theory of consumer behavior. And before that, I need a little bit understanding from you, or maybe a little bit involved differentiation techniques. For that, the key rules of differentiation I'm going to show you. Maybe you must familiar with those differentiation rules. Help to when you discuss the especially demand theory of consumer behavior, theory of production, and after that the market structures also. Yeah. This is the what I'm doing, since maybe you haven't done those things in the statistic or any other subject. If you have done, I don't need to do that. I think I don't know whether too early, or if you have done, tell me, then I don't need to do that. So tell me what you have done or not. The differentiation, the statistic or mathematics have done. Anyone? So no one answer. That is the, I don't know, is the culture in the class. So
those are not yet done.
You have done.
Not done.
Okay. Now just I'm going to introduce, but I'm not going to teach properly what to how to do, and the example and all those things I have to do. So this is the key important rules of differentiation. Now the first rule, what we have to understand, what we have to know, to differentiate a constant function. So for example, let's say y equal 5. Before that, the symbol, what I'm going to differentiation, is about quite similar to the slope. And if I differentiate this let's say equation what we have y is a function of x. So in all only two variable, we use the dy over dx. Let's say the y is differentiated with respect x. If we more than two variable involved, we use the different symbol, but the same concept we call daba y over daba x. So that's the first differentiation. You can do second differentiation, third differentiation, depend on the equation, and the cross differentiation also is basically. And the basic idea, if you look at deal with the equation for curve differentiation, first differentiation is the slope. Of the equation. That's mathematically, if you look at the root and different meaning you get, but quite get a simple idea. This is about the slope of the equation. Now, if we go back to the differentiate the constant term, in that way you can see the dy differentiate with respect x. Let's say x is the dependent variable. So here in the constant term, then it becomes 0. Between any constant term, if we differentiate, the answer is 0. And also sometimes I use the symbol to differentiate like this also. So it means the y difference, this function differentiate with respect x. Or maybe sometime I use the symbol like this also. Here. Differentiate with respect x. For example, here I can use here, or I would use that's also difference wave writing. Now, the second rule, what I'm going to show you, differentiate of a linear function. The linear function, kind of function like this, f x or y is function of, let's say, some numbers, 2x plus 6 or something, like a supply function or demand function like that. Now, when you differentiate the function, differentiate with respect x. Now, if I write a general form, let's say that this is coefficient as m x plus 6. So when you differentiate here, the value is only 1. Ultimately, answer comes m. So simple linear function when you differentiate, that is equal. Okay. That is a very simple thing. And the further expand third goal, the power function, how to differentiate. power function. Something like this, let's say y equal of this equal 3x, let's say power to 2, this kind of function. Okay, to understand, let's say the function is like this. Here, of t, let's say I write m, that's the coefficient, and x is power, I'll write n power. So when you differentiate this kind of power function, what you have to do, differentiation with respect x, you take this m and multiply by here, whatever the coefficient here, which means n multiply m x. Here you have n, after differentiate become n minus 1. Now, if you look at this example, so what we get the answer, here 2, here 3, 2 multiply by 3, 6, 2 multiply by 3, x, 2 minus 1. The answer become 6, 6. That is the slope of, anyway, this equation. Another quite important, that is also very simple, some more different of pair function, like let's say fx 5x minus or plus, I put minus plus here, 3x4. So sum of the pair. Apply the second, that's the third rule, both, that's very easy. Then the differentiation, when you do, is come x. First differentiate this one separately. The answer come at 5, because the here 1, that when you differentiation 1 multiply by 5, 5. So x 1 minus 1. So that becomes 0. X 1 minus 1, 0 power, which means the number 0 power equal to 1. Okay, now then plus, here 4 times 3 is 12 x. Here 4 minus 1 is 3. So that is the next one. Then we will take product of two functions, the differentiation. That is also important for us. So I'm not taking all the things and important thing. Product of two functions. Product of two functions. Something like this. Let's say the total revenue of a firm or product. It's a demand equation you have minus 2Q as a one product, one function. So if multiplied by Q with another product. So product of two functions. So when you differentiate this Q, so what the answer you get, let's say this is two function. The first part, let's say fx or fq, we can use, let's say fx first part. Second part, let's say second function gx. Now if x mean 40 minus 2q, yes mean just here q. When you differentiate the first differentiation, when you do, here first part you differentiate with respect x and multiply the second pass at it plus second part you differentiate and multiply by the first part. Now, for example, this one, the first part is a 40 minus 2q. When you multiply, differentiate here, come to minus 2. Second part as it is side, q plus, then this part, second part differentiate, q differentiate with respect is getting 1. The first part as without differentiate to right. So after that you can simplify and you can get the answer. So give another example. So you can do yourself. Let's say the two function here, 30 q plus 5 q power 2 and 2q minus 6 plus 6. That equation, same thing you can apply. And this part, let's say label x. This part you label x, then you can do. So that is the product of two functions. Another also think important for us later on, derivative of the quotient of two functions, like something like this. Let's say y equal 10x (3x4) divide by 2x3, let's say minus 5. So we call quotient rule. So they are quite simple. Again, let's say the first numerator we label fx, and the here numerator we label gx. Now when you differentiate this one with this equation, so the first we will look at the gs here, numerator. We write value here as a power in here is coming the first part with the numerator differentiate and write the equation as it is. The minus, they always come minus. The opposite reverse do g, the equation differentiate with respect. They are the f equation, right, as it is. So if you apply this to this particular equation I gave you, here the answer coming 2x3 minus 5 equal and raise a power. Then after that, the first part, if you differentiate this part with respect to x, you get n plus 12 x3. That part we write first, n plus 12 x3, then multiply by the here g equation, that means 2x 3 5, and then the minus sign come here. Then the differentiate this g equation after differentiate come, answer become 6x. So then here write 6x, and the fx equation right as it is here like that, which means 10x plus 3x4. Then you can simplify. This is a very important quotient rule. You have to understand. Of course, that's the key thing what you I need from you to understand. Another one very important rule of chain rule. the differentiation. The equation like this, let's say y equal x4 minus, let's say, 55, and let's say here 20 power. So here also what we can do, this part maybe we can use as a u. Then you have equation y equal u 22 like that. But you know u equal x power 4 and minus 22. When you differentiate this, now what happens? Let's say with respect y with respect x equal, you differentiate with first y with respect u, then du equation with respect x. Now simply if you look at here carefully, here to here cut, they come back to the same one. Now in our example, if you differentiate the first part du dy with respect du, so you can see the answer from previous rules, you get in 22 u 21. So that is this part 22 u 21. Now the second part of the equation here, now you know this is the u, differentiate with respect x. So when you do so here, u is x power 4 and the 54, then become 12 x power 2 3. So that you write here, then you can simplify and you can get the answer. Simplify mean the basically you can multiply. But here get the answer with the u, then you have to replace this u here. Then answer become 22. We know u equal dx 4 minus 52, that is a u, and power 3 also we have to add. Multiply till x3. And simplify, you can get the answer. So those are the simple things. And also another one, sometime we use some kind of, but it's not the theory of consumer behavior. I'm not going to, but exponential function, like here, e the power of x. When you differentiate this, whether y equal with respect x, dy over dx, the answer become same x. So here nothing changed actually. Finally, if you look at the function, the logarithm, natural log function, when you differentiate, let's say lns, natural log, here x, when you differentiate this one, the y equation with respect x. In that way, you get an answer y1 divided by x. For example, let's say the equation y equal ln 5x power 2 minus 3x. So if you differentiate this one, the answer you get the next minus 3 multiplied by 1 over 5x2 minus 3x. So these are the key rules you have to understand if you want and look at some materials and try to understand those rules and the differentiation rules. Yeah. And with that, we must know how to do high order differentiation, which means the first order, second order differentiation like that. Now, what we did right now, simply the first order differentiation like that dy over dx. Some equation you can differentiate the first order, second order, and different orders also. For example, let's say y equal 5x4 minus, let's say 3x. Now, when you differentiate the first order here, the answer becomes 20x minus 3. Now, second order differentiation, when you write symbol here, dy.
Pencil one, all pencil petty gin can me amma pencil.
Y dx. So that okay. Also you can write like this also. That's also second order differentiation. And also you can write like this also. 2 times differentiate with respect to x. So here the first time already did. Now if you differentiate the what you've done right now, second part, second equation, this is the first one. That's what we call second order differentiation. Here 3 times 20, 60 x2. So this further differentiate you can, because here 2, you can do the third order differentiation also. So become 2 times 60, 120 x. You can do further differentiation, and the fourth time also you can go up to that, which means 120 is the answer. Now you can see if you put it to graph now, sorry, the fourth differentiation just like this, constant term. Now the third order differentiation is coming if you separately draw a graph. Here, it's something like goes like this. 120 x. Second order differentiation is the nonlinear and the kind of curve kind of coming. And you can imagine and you can draw those, that purpose at the end we try to get, or we try to understand. Yeah. Now, the other important thing is with the differentiation, we should be able to understand whether the function is, you should be able to understand also the function as a convexity or concave, or maybe simple word if you have the maximum point or minimum point. That's another important things you must understand. Or which value you get the maximum point, or which value you get the minimum point. Or the area you get the convexity, the area with the concavity. Now for that, get the slope, like I said, understand the slope, like I said. The first order we'll call necessary condition, the minimum or maximum point. The first differentiation has to be equal. There you get the turning point, the maximum or minimum or whatever turning point. So how do you understand whether the equation has convexity and concavity? So it's a convex. If you differentiate the second differentiation in case of convex, the value is positive. Convex. Concave, after second differentiation, the value is negative. So that's how you understand whether the function is convex, or the area of the function you get the convex property and the concave property. So when you differentiate the second time, the value you get. Yeah. Now, the one example, let's say fx equal minus 2/3 x3 plus 10x plus 10x, the power, and the plus 5x. Now what we have to do, differentiate this equation twice and try to get a sketch of the curves and identify the convex, because this has both properties, convex and the concavity. There's some. So first we have to do this exercise, differentiate twice. Then you can find the value where the border or turning point coming. So first differentiation, send me the answer, then we will go on. We will continue. nobody has answer, which means maybe nobody there. So then I also don't do that. And yeah, somebody has done. Okay. Shani, Prabhat. Now first, we differentiate this one. When you differentiate, first order differentiation, the answer become minus 2x power 2 plus 20x plus 5. So there, if you set to equal to find the answers, you get the turning point at the maximum or minimum value. So we are not doing yet this point. And the second order differentiation, second equation we differentiate again. So that what happened, minus 4x in the minus 4x, here 20. Now point here, when you draw the curve, the value is less than 0, parent value. Now let's say here, x, here y. It become negative. Then you get the concave. So that part of the equation, you get the concave property. If value is less than 0, you get that part, you get the convex property. Now look at the x become greater than 5. X become 5, it's 0. X become greater than 5, the value become negative because for example, x let's say 6. 6 times 4 is the 24. That's a negative value. Here 20. Ultimate answer is negative 4, which means, let's say 5 is here, x value. This part, after this part, this particular equation, you get the kind of property, let's say, somewhere either connect and come to the maximum. And less than 5, here let's say 4, x equal 4. 4 times 4 is 16. Here 20. Ultimate value, you get the positive sign. So you get the convex property. So which means this part of the equation like this. Now here this is the turning point in the sense it go to convex. So if this kind of equation you get, yeah. Now the last point here for us important to find the optimal value, consumer optimization, maybe optimum utility, profit optimization, that's the case of production, those kind of things. we have to, for that, we can say the maximization or minimization, very simply, maximization or minimization, which means you are going to find the minimum value or maximum value, or we call optimization, optimal value. Could be a minimum or maximum, but optimization. So there are two conditions has to satisfy the equation. The first condition, what we call first order condition, or another name we call necessary condition. So that necessary condition. So necessary condition is, let's say, we'll take a profit function. Here, like profit function. The first order condition, let's say profit function we differentiate with respect to this is something profit function 5 q p minus 3 q. If when you differentiate this one, the first you multiply 15 here, q 2 minus 3. It is equal, set equal to then get the value here, q. Now 15 q square equal 3, then the value to q you can find that value is the minimum or maximum point. It can be a minimum, can be a maximum point. Because this is set equal to 0, the first order condition, there you get the slope. Now 0 means you go to the negative point because their slope is 0, or maybe you the positive point here, there also slope is 0. So we don't know still what is this negative point or a concave point, convexity point. For that, we have to go for second order condition, which means if you differentiate the second order condition, or what we call sufficient condition, what does mean if you now you differentiate this equation one time, so differentiate again what we call second order differentiation. Now, if that happen, profit function become 15 because 2 multiply 15 and the q is the answer. The value second order differentiation is negative. The value of the second order differentiation is negative. We say we have the maximum value. And then we go to maximum point and come. If the second order differentiation value, you get the positive point, positive value. So there we can conclude that the equation we have minimum point like this. Minimum point like that. So simply the second order differentiation value you get negative, you get the maximum point. If it is the positive, you get the minimum point. Now I'll give you a very simple example. There you find the optimal point, and if possible, draw the curve also. So the equation is a y equal let's see, 2x, sorry, x power 2, 1. Here I'll put minus x power plus 2x1 minus x2 to the power. And plus 4x to minus 5. So this is the equation. What we have to do, the optimal point, the value of x1 and x2. So there, later on you can see, you can find it a minimum point or maximum point. So optimal point, value of x1 and x2. And so here you can see the key variable y, x1 and x2. There we can do differentiation. Cross differentiation means if you differentiate first with one variable, let's say x1, then you differentiate the next variable with say x2. So that's what we call cross differentiation. Here this equation you can see x1 and x2. And there, either way you do, first differentiate with respect x2, then x1, you get the same result, no difference. You can do differentiate this one and check. That rule, what we call the cross differentiation, we call Young rule, Young. So according to Young rule, the cross differentiation, it doesn't matter the order, you get the same result. You get the same result. Now, find the optimal, the value, the x1 and x2. For that, what we have to do, first differentiate with respect x1, then x2, then find the value to x1 and x2, the other optimal value. So you can do, I'll give 2 minutes. some of you have done, and tell me the answers also. Now the first order condition, if you look at, differentiate with respect x1, you get the minus x1 plus 2. So the maximum or minimum value, the first order condition, this has to be equal to 0. So that you can see the x1 equal 1. So there you get the optimal point. The x2, when you differentiate, it become minus 2x 2. Here the plus 4. They are also equal to 0. X2 get the optimal point at 2. For the profit maximum outcome or the optimal value, we get the one x1, the other is 2, we count 2. With that, I'll stop here. The basic things related to differentiation and get to understand the equation. Now let's say y equal, let's say demand 65 minus 2p power 3. Now if you differentiate this one with respect to p, we get the slope 6p2. This is the slope of the demand curve. It's negative here, so you can see that predict the law of demand, that say accept the law of demand hypothesis. So with that, I'll stop here. So I'll give you about 10-minute break. Now, so I will continue after 10 minutes, that is 2:20, because the new session I am going to start. So I need a small break, or maybe you also need, because this is the difficult time. So we will, after the break, small break, 2:20. I will take the theory of consumer behavior, start the discussion at time 2:20.